we check concavity?
The second derivative.
We use the second derivative for concavity. So what's my second derivative?
24x squared minus
24x squared.
that's 48
I'm listening to y'all, but I'm not looking at it.
minus 48x.
Do y'all agree? Alright, I took the second derivative. What are we gonna do with this now?
Z equals 0.
So now I have 24x squared minus 48x equals 0. How you gonna solve this?
Factor
Factor out what?
24x.
So that's 24x times x minus
2.
how much?
2.
So now that means that 24x is 0 or x minus 2 is equal to 0. So what's here? X is equal to how much?
0.
Or x is equal to?
2.
Alright, you got those. What are you gonna do with them?
The chart.
What are you gonna do with this now?
Find the critical points.
How you gonna find them?
By plugging in.
Okay, so you can plug them in. But remember, the second derivative is used for concavity. We do the same thing we did with the first derivative. We're going to set up a little chart. We set a chart using the second derivative. And the values we have are what? 0 and what's the other one?
2.
What value you like to test here?
-1.
What value you like to test here?
1.
What value you like to test here?
3.
So I'm going to find f prime of double prime of -1, which is 24 times -1 squared minus 48 times -1. What's 24 times -1 squared?
24.
So they tell me this is 24, and a -48 times -1.
Positive 48.
So what's the answer to this going to be?
32. Yeah.
Which is positive. So you know the graph here is concave which way?
Up.
And then I put in 0. No, 1. And I get 24 times 1 squared minus 48 times 1. Which is 24 minus what?
48.
Which is negative,
24.
positive, negative.
Negative 24.
So this is negative, so the graph is concave which way?
Down.
Something's wrong. We good? We good. And then class, we're going to put in 3. And I have 24 times 3 squared minus 48 times 3. And what's 24 times 9?
216.
So we have 216 minus 48 times 3.
144.
And 216 minus 144 is?
Oh no, it'll be positive.
How much? 216 minus 144?
72.
70. So I asked you to find the intervals where it's concave up and down. So you can tell me it's concave up where?
0. Negative infinity to 0.
Negative infinity to 0, and then from?
2 to positive infinity.
And it's concave down where?
0 to 2.
We good? And part 6 says, find all inflection points. No, this is six problems. This is 6 problems. So it says find all inflection points. Let's put it this way. You can do it now, or you can do it later.
With notes, with guidance.
You can learn it now, or you can learn it later. Show us. We good? So find all inflection points. How you find inflection points?
Would you plug in?
What's an inflection point?
The shift.
Change what? What mean up to down?
Concave.
We had this in class yesterday. Y'all take any notes yesterday?
You said an inflection point is a point occurs when the continuous graph change from the concave upward to the concave down, or vice versa.
Okay, can y'all interpret that, what they mean, and tell me what the inflection points are? Do we have any?
Yeah.
Why do you say we have some?
Because it's changing from up to down, go back
So
up.
you just see it changes concavity. This is up and this is what? Down. So I know I got an inflection point at where?
Zero.
So inflection point at 0 what? F of 0? 0, F of 0, and the other one will be at where? 2, F of what? 2? Now, in that case, not class, if you put in 0, you already know you're gonna get how much, class?
0.
Now you have to find F of 2, we haven't done that yet. So F of 2 is?
8 times 24.
2 times
2.
To the power of 4 minus 8 times 2 to the power of 3.
and 2 to the 4th is? And 2 times 16 is?
32.
And 2 cubed is?
8.
And 8 times 8 is?
64.
And 32 minus 64 is?
Negative 32.
So that point there is 2 negative what? 32? We good? So we go to problem number 7, and it says use number 1 through number 6 to sketch the graphs. Use parts 1 through 6 to sketch this graph. Now, if you remember when we first started this, we found the critical numbers. Then we found 2 critical points. What are my critical points?
3.
3 what?
3.
One of them was the first critical point.
Oh, 0, 0.
One of them is 0, 0. You good, class? What's the other one?
3. Negative 4. Negative
3 what?
54. Negative 54.
And what did the graph start off doing?
Decreasing.
So you're going to graph is decreasing. And while it was decreasing, Which way is it concave? So that means this little part right here, when it looks something like this, cause it's concave which way? We good, class? And it's coming down, but it's bent up. We good? And then, after we get to zero, class, what the graph still do?
Go down.
It's still going down, yes, no? It goes down to get to where? To get this point right here, yes, no? Then what the graph do?
Goes up.
And this is the graph. Now in here, class, you have two inflection points. And one other inflection point occurred at the point 2 negative what?
32.
And if y'all look at this part here is up, this is down, and this has been up, and that's the graph. Now this is life. You're in my class taking Cal 1. I expect you know how to do this. The first derivative to tell you about increasing and decreasing. Now, I think there's something wrong with you. You can take the first derivative and set it to degree 0, put it in the chart. See when it's positive, see when it's negative. I think there's something wrong with you.